So currently at Alauda, there's many projects that are happening in parallel, all with one shared goal of getting the most out of the Mk3 heading into our race series early next year. Current project that we're working on is the development of a battery access panel system, which basically allows us to reduce our flight-to-flight time. So it's the pit crew will be very thankful for this because it means that they're not near the vehicle for as long as possible, and the pilots will also be benefited because they're on the ground for as little time as possible. Yeah, so we're down here working on the battery access panel solution down here in Hangar 15. The solution that the team's come up with is a sliding panel solution. So the way in which this will work during operation is that a pit crew will approach the vehicle, they'll slide the tail and canopy sections back, they'll then have top-down access to place the batteries in the vehicle and secure them. Slide that panel all the way forward again, it'll secure in place, and then they can leave the vehicle and the vehicle's now got a fresh set of batteries and it's ready to fly. Right now our current system is sitting at about a 2-minute flight-to-flight time. With this iteration of the battery access panel system, we aim to get that sub 1 minute, and then beyond that, in the next iteration, we're hoping for sub 30 seconds. Now, with all this being said, we still need to maintain the system's integrity and also operational personnel safety, and we'll do that through our design process and also our operational procedures formulation. We're aiming for a sub 30-second flight-to-flight time so that we can get the Mk3 in the air for as long as possible.
So obviously it's experimental flight tests, so experimenting can be dangerous. One of the most important things is we keep it safe, but at the same time we want to progress the program. So first-person view is a crucial part of that, and it creates what we call representativity. It represents what it would be like for a pilot to be on board without actually putting him on the aircraft himself.
So to be able to operate a speeder from first-person view, there's many things that we have to tie together. A lot of that's from a system verification and validation stage. So we can do that on the vehicle, test our systems, make sure that all of our components are functioning, and enter fail-safe when they don't function. Another important level besides the system validation of FPV is to make sure that all of our operational procedures are in check. So we need to work closely with the regulator to make sure that we're operating safely and in accordance with those requirements stipulated by CASA.
With any aircraft program anywhere, the number one thing you always want to be on top of is weight. Weight matters. Weight leads directly to the efficiency of the aircraft, your range, your endurance, and of course, for us, your speed, but also your maneuverability. So, we've done a very important exercise beginning 6 months ago in reducing the weight of the vehicle, and then actually doing that, also improving the moment of inertia, which means that we can get the vehicle to be more agile and responsive. Our pilots, once we debuted the vehicle with them, immediately noticed the difference over the original version and the one that had undergone this exercise. And that's made the vehicle more dynamic, it's made it faster, and it's going to be a continual process because as engineers, you always want to be sharpening your pencil. So we're going to be constantly looking at ways to reduce the weight of the aircraft, to make it more nimble, to make it faster, and just really make it exciting for the viewers who are going to be watching this event.
As we get close to wrapping up another year here at Alauda, we're getting pretty busy. Our main focus at the moment is getting approval for EV loss operations, which will give the pilots better perspective and be able to push the aircraft further towards its limits.